Hello everyone, I am Nirmith Kumar Mishra, working as Assistant Professor in the Department of Aeronautical Engineering, and I welcome you to the course Unmanned Air Vehicle Design. The first topic in this course, we are going to see about historical developments of UAVs, classification, and few successful UAVs. UAVs are remotely piloted or autonomous air vehicles carrying payloads like cameras, sensors, and communication systems. The basic terminology which we use here is UAV, also called as Unmanned Aerial System, which is preferred by the Department of Defense, and globally it is known as drone, which is commonly used in media reports and social media platforms. We conduct these UAVs. These UAVs are to conduct critical missions without endangering personals and at a lower cost than a manned aircraft. UAV design follows principles of engineering design. It involves analytical processes. It involves drafting and visualizations, problem solving techniques, and modern UAV design requires optimization and computational analysis. This computational analysis includes structural analysis, fluid analysis, thermal analysis. Research on UAVs has expanded significantly over the past 2 decades, and it is focused on endurance and range. When we talk in terms of fuel-based aircraft, this endurance is the flight which it covers in one payload of fuel. And when we talk about range, it is the flight which it covers with one payload fuel load, the distance which is covered. For example, this is a mission profile of any aircraft, manned aircraft or unmanned aircraft. This is a basic mission profile. So, with one payload of fuel, from starting point A to starting point B, the distance which is covered with one payload of fuel is called as range. And the flight time between A to B is called endurance. With one payload of fuel, the amount of time which aircraft spends in time is endurance. Modern UAVs cater to diverse applications. Applications span both civilians and military. Under civilian, we have surveying, logistics, agriculture, and under military applications, we have reconnaissance, surveillance, and combat. Early performance assessments in UAV design include cost, manufacturability, and operational effectiveness. UAVs like Predator and Global Hawk exemplify advancements in UAV technology. This Predator and Global Hawk are US based designs which are globally used. FAA Regulations 2016 was the first operational rules for commercial UAVs, and FAR Part 107 defines small UAVs which are less than 55 pounds or 25 kg. These restrictions are under Part 107. It should have maximum altitude of 400 feet, and above ground level it should be 500 feet but below the clouds, and it should have a 3-mile visibility. UAVs share design principles with manned aircraft but face unique challenges: structural constraints, the G loads and pressurization, integration of autopilot, ground stations, and communication systems, advances in autonomous systems and AI integration, use of multi-objective genetic algorithms in UAV optimizations. These are the few design challenges which a designer has to go through during his designing phase. Early UAVs were based on full-scale aircraft principles. Computing advancements have enabled detailed UAV configuration analysis, and UAVs must operate in controlled airspace with advanced navigation and control systems. UAV system consists of 5 major elements: environment, which includes airspace, data links, and relay UAVs. Air vehicle element, the UAV itself. Third element is mission control element, which is from ground control stations. Payload elements are cameras, sensors, and other equipment as per the objective of the unmanned air vehicle. Its support element includes maintenance, logistics, and support systems. Countries are using UAVs for civilian, military applications, including US, China, Israel, India, Russia, UK, France, Germany, Turkey, and others. As of 2025, the utilization of UAVs have expanded significantly across both military and commercial sectors. In 2024, global commercial drone flight hours reached approximately around 10.8 million. General Atomics Predator series unmanned air vehicles continue to dominate UAV deployments worldwide. In October 2024, the Indian government finalized a $4 billion agreement to acquire 31 MQ 9V Predator drones, aiming to bolster surveillance and defense operations, particularly along its borders. The integration of these advanced UAVs is poised to significantly enhance India's intelligence, surveillance, and reconnaissance, with the capabilities contributing to national security and defense modernization efforts. UAVs are revolutionary. Industries like energy, telecom, construction, and agriculture, they are utilizing it. As of January 2025, the DGCA in India has been actively advancing the integration of UAVs into civil airspace. In July 2024, the central government has increased incentives for drone manufacturing by 37.5%, allocating rupees 165 crore over 3 years to bolster the domestic drone industry, which has boosted the startups in the field of unmanned aerial vehicles. The DGCA is also developing a comprehensive regulatory framework for advanced air mobility solutions, including electrical, vertical, takeoff and landing aircrafts. The initiative is to manage UAV operations strategically and tactically by optimizing air traffic flow through unmanned aircraft, traffic management systems integrated with existing air traffic management systems. UAV design follows 3 major phases: conceptual design, which is an initial feasibility and performance assessment; preliminary design, where structural, aerodynamic, and mission analysis is performed; detailed design is full system integration and optimization. Classification of unmanned air vehicles. Unmanned air vehicles have diverse applications in military, commercial, and research fields. Depending upon its cost, size, weight, mission, and users, this varies. Based on weight, we have micro air vehicles, which is less than 1 pound, mini UAVs, which is less than 1 to 25 kg, with a maximum takeoff weight of 25 kg. Small UAVs vary from 25 kg to 150 kg, where maximum takeoff weight varies between 25 kg to 150 kg. Medium UAVs range from 150 kg to 600 kg, where maximum takeoff weight is 600 kg. Large UAVs weigh more than 600 kg, where maximum takeoff weight is above 600 kg. Based on mission, the unmanned air vehicles for military applications comes under the category of reconnaissance and surveillance to monitor enemy activity. One of the most widely used unmanned air vehicle for reconnaissance and surveillance is Global Hawk. Combat UAVs like X-45 is used for strike missions, where they are used for air-to-air strikes, air-to-ground strikes. Electronic warfare, it's a UAVs which is used for disrupting enemy communications. Based on mission, one more category is communication relay, which is used in disaster response to enhance network coverage. Logistics, where UAVs are used for supplying the response to the needed people. Research and development, under this, the air vehicles are used for atmospheric and environmental studies. Apart from that, even for mapping on mountains or crop fields and on the grounds everywhere, it is used for mapping, doing the surveying, so that it can take the pictures and study it whether the place is suitable for mining or not. Based on tactical rules, we have micro UAVs, which is less than 15 centimeter in size, developed for military operations by DARPA. Tactical UAVs support tactical commanders with real-time intelligence. For example, Outrider and Hunter, these are two unmanned air vehicles which are under this category. Male UAVs, it is medium altitude, long endurance UAVs for surveillance. Example, Predator is a drone which is used for medium altitude and long endurance. Hail UAVs, high altitude, long endurance UAVs for long range operations, for example, Global Hawk. Based on airspace classifications, we have category G, which will have drones like micro, mini, small UAVs and quadcopters. Under the category A, we have male UAVs. Under the category B, C, D and E, we have tactical UAVs. And large UAVs requires transponders to declare flight characteristics. UAV is classified based upon its class, weight, and all the classes will have its weight, size, normal operating altitude, range and endurance. For example, micro class will have range of 0.1 to 0.5 kilometer with an endurance period of less than or equal to 1 hour. Mini unmanned air vehicle will have range of 0.5 to 1 kilometer with an endurance period of less than or equal to 1 hour. Very small UAVs will have range of 1 to 5 kilometers with endurance period of 1 to 3 hours. Small unmanned air vehicles will have 10 to 100 kilometers with an endurance period of 0.5 to 2 hours. Medium unmanned air vehicle will have range of 500 to 2000 kilometers with an endurance period of 3 to 10 hours. Large unmanned air vehicle will have range of 1000 to 5000 kilometers with an endurance period of 10 to 20 hours. Tactical and combat drones will have 500 to 2000 range with an endurance period of 5 to 12 hours. Male unmanned air vehicle will have range between 20,000 to 40,000 kilometers with an endurance period of 20 to 40 hours. Hail unmanned air vehicle will have a range of 20,000 to 40,000 kilometers with an endurance period of 30 to 50 hours. Quadcopters will have range of 0.1 to 2 kilometers with an endurance period of 20 minutes to 1 hour. Helicopters will have range of 0.2 to 5 kilometers with an endurance period of 10 minutes to 2 hours. So these are unmanned air vehicle classified based upon weight, size, normal operating altitude, range and endurance. As per DGCA, these unmanned air vehicles are classified into categories nano, micro, small, medium and large. Nano drones will weigh up to 250 grams with a maximum takeoff weight of 250 grams, and micro class unmanned air vehicle will have more than 250 grams and up to 2 kg with a maximum takeoff weight here will be 2 kgs. Small unmanned air vehicles will be having weight more than 2 kgs up to 25 kg and the maximum takeoff weight will be between 2 kg to 25 kg. Medium class unmanned air vehicle will be having weight of more than 25 kg up to 150 kg. And here the maximum takeoff weight will be varying between 25 kg to 150 kg. Large unmanned air vehicles will have weight of more than 150 kg where maximum takeoff weight will be greater than 150 kg. UAV configurations are into two categories: fixed wing unmanned air vehicles, rotary wing unmanned air vehicles. And there is also one more configuration which is a hybrid of these two, fixed wing and rotary wing. Fixed wing unmanned air vehicles requires a runway or a launcher for takeoff, whereas a rotary wing can take off and land vertically. It will have a feature of VTOL, and this will be short takeoff and landing or conventional takeoff and landing. Fixed wing unmanned air vehicles are used for high speed, long endurance missions, for example, MALE UAVs and HALE UAVs. And whereas rotary wing unmanned air vehicles includes unmanned helicopters and quadcopters. These apart from these quadcopters, even tricopter is an example for this. Bicopters, tricopters, hexacopters, quadcopters, these all comes under the category of rotary wing unmanned air vehicles. One of the example for this is Yamaha R Max, which is an unmanned helicopter with a maximum mass of 94 kg and an endurance of 1 hour. Few successful unmanned air vehicles: Global Hawk, which is made by Northrop Grumman in the year 1998 with the objective of intelligence, surveillance and reconnaissance. And it is the first unmanned air vehicle to autonomously cross the Pacific, which is a Guinness record. It operates at high altitudes for long endurance. It has a wingspan of 39.9 meters, length of 14.5 meters, and maximum takeoff weight is 14,628 kg. It uses Rolls-Royce turbofan engine. And it has a speed of 340 knots. That's the maximum speed. Cruise speed is 310 knots. If this is a mission profile, this segment is called cruise. This is ground roll, takeoff, climb, cruise, descent, land. Right. So during this, its speed will be 310 knots. Range is 22,779 km. For example, from point A to point B, this range, right, this will be 22,779 km in one payload of fuel. Endurance is 32 plus hours. So, from this point to this point, it can fly up to 32 plus hours. This is the endurance time. Service ceiling 60,000 feet. This is Global Hawk, US Air Force. RQ-170 is one more unmanned air vehicles which is made by Lockheed Martin. Mission is stealth reconnaissance unmanned air vehicle. Stealth technology is used to ensure it is not detected, right? It will not be detected by the radar, right? And it is used by the CIA, which operates at high altitudes with low visibility. It's a tailless stealth unmanned air vehicle. If you see here at this part, there is no tail here. And the primary use of this unmanned air vehicle is to gather intelligence information. During this lecture, we have seen that UAVs continue to evolve with advancements in AI, automation, and aerodynamics. Design challenges involve balancing cost, payload capacity, range, and mission objectives. Future UAV development will focus on autonomy, endurance, and multi-role capabilities. UAVs have a broad range of classifications based on weight, mission, airspace, and military application. They play a crucial role in military operations, commercial applications, research, and disaster response. Future unmanned air vehicle developments focus on swarm technology, artificial intelligence, and extended endurance capabilities. These are the references used for the lecture. Sadr Mohammad H, Design of Unmanned Aerial Vehicle Systems, Aerospace Industries Association, AIA, and Federal Aviation Administration for the rules and regulations on unmanned air vehicles, and DARPA, their programs on design of micro air vehicles, and this is DGCA's guidelines for unmanned air vehicles. Thank you. We'll continue the next lecture.